Hello, in this lecture we'll find out the length of line segment X using two different methods. In the drawing we have quadrilateral ABCD. We know that side AD equals to 3 units, side AB equals to 5 units, side DC equals to 6 units, angle ABC equals to angle DCB, and they are both equal to theta. Angle ADC, this angle equals to 90 degrees, and we want to find out the length of side BC that is actually equals to X. So we start with the first method. In the first method, we will extend side BA and side CD by a straight line until they intersect with each other. This point is the intersection point between the extended side AB and the extended side CD. So we define this point as point E. So actually we created here triangle EBC. In triangle EBC we have two angles that are equal to each other, they are both equal to theta. So first of all, I will present to you a new rule that is actually rule number 1. According to rule number 1, in front of equal angles in a triangle, there are equal sides. I read rule number 1 again. According to rule number 1, in front of equal angles in a triangle, there are equal sides. So, if we focus on triangle EBC, this triangle ABC. According to what is given us in the question, angle EBC, this angle is equal to this angle, that is angle ECB, and both angles are equal to theta. Okay, I'll repeat again. Angle, according to what is given us in the question, angle EBC equals to angle ECB, and they're both equal to theta. So according to rule number 1, we can conclude from it that side EB is equal to side EC. Okay, side EB equals to side EC. Okay, because of the fact that in front of those two equal angles there are equal sides, it means that EB must be equal to EC. But EB equals to 5 plus AE, while EC equals to CD plus ED. CD equals to 6 plus DE. So in conclusion, CE equals to 6 plus DE. So we actually found out that 5 plus AE equals to 6 plus DE. According to equation number 1, we'll subtract 5 from this equation, equation number 1, and we get that according to equation number 1, AE equals to 1 plus DE. Again, according to equation number 1, AE equals to 1 plus DE. Okay? We will define DE as A. So DE equals to A according to our definition, so we can substitute DE by A, and we get that according to equation number 1, AE equals to 1 plus DE, that is A, so AE equals to 1 plus A. AE equals to 1 plus A, so we can write here that AE equals to 1 plus A. Okay? Here we have EC, line segment EC is one side of triangle ABC, therefore it is absolutely a straight line. Okay? And in addition, before the construction, we had quadrilateral ABCD, and CD is one side of quadrilateral ABCD, therefore it is a straight line, and we extended the straight line CD by a straight line, and in this way we created line segment EC. When you extend a straight line by a straight line, the result must be a straight line. Therefore, CE is a straight line. So we can write down that CE, line segment CE, is a straight line. Okay? Line segment CE is a straight line. And we have rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. I will read rule number 2 again. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. So here we know that EC is a straight line. If EC is a straight line, so if we focus on this side of the straight line EC at point D, then according to rule number 2, the sum of the angles on this side of the straight line CE at point D must be equal to 180 degrees. So which angles we have at point D? We have here angle, this angle that is a right angle, it is equal to 90 degrees plus angle EDA. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. So at point D, at this side of the straight line EC at point D, we have 90 degrees, and we have also angle EDA. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. We will subtract 90 degrees from this equation, and we get that the missing angle EDA, is equal to 180 degrees minus 90 degrees, it is 90 degrees. So we found out that this angle EDA equals to 90 degrees. So if angle EDA equals to 90 degrees, it means that triangle EDA is a right triangle. So we can implement the Pythagoras theorem on this right small triangle, triangle EDA. According to the Pythagoras theorem, on the right small triangle EDA, here by PT is the abbreviation for Pythagoras theorem. So in the right small triangle, triangle EDA, we will get that AE squared, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AE squared equals to AD squared plus ED squared. And repeat again. According to the Pythagoras theorem, in the right triangle, triangle EDA, AE square equals to AD square plus ED square. This is equation number 2. So here AE equals to 1 plus A, so we substitute AE by 1 plus A. If A equals to 1 plus A, then AE square will be equal to 1 plus A square. And it is equal to AD square. AD equals to 3, so AD square is 3 squared, that is 9, plus ED square. ED equals to A according to our definition, so ED square will be equal to A squared. In conclusion, we found out that according to equation number 2, 1 plus A squared equals to 9 plus A squared. Here we will open the brackets on this side of equation number 2, and we get that according to equation number 2, one plus A square equals to 1 plus A square plus 2A, and it is equal to 9 plus A square. Here, in this equation, equation number 2, we have A square on both sides of equation number 2, so A square will get cancelled, and we left only with 1 plus 2A equals to 9. Here we'll subtract 1 from this equation, equation number 2, and we'll get that according to equation number 2, according to equation number 2, 2A equals to 9 minus 1, that is 8. Here we'll divide this equation, equation number 2 by 2, and we'll get that A equals to 8 over 2 is 4. A equals to 4. So here we actually found out that A equals to 4. Therefore, 1 plus A will be equal to 5. We will define angle BEC. This angle is angle alpha. So in the green right triangle AED, the green right triangle AED, here cosine alpha equals to ED over EA. I repeat again. On the green right triangle AD, cosine alpha equals to ED over EA. ED equals to 4, so we substitute ED by 4. And EA equals to 5, so we substitute EA by 5. So in conclusion, we found out that in the right triangle AD, cosine alpha equals to 4 over 5. Cosine alpha equals to 4 over 5. In the next step, I will present to you a new law that is the law of cosines. According to the law of cosines that is true in any triangle, if we have triangle ABC that could be any triangle, and we know that side AB of triangle ABC equals to A units in its length, side AC equals to B units in its length, and side BC equals to C units in its length, and the angle between side AB and side AC is alpha. Then, according to the law of cosine, we will get that C square equals to A square plus B square minus 2 times A times B times cosine alpha. This equation is true in any triangle. So we will implement the law of cosines in our triangle EBC. Okay, so in this triangle EBC, we will get that according to the law of cosines, BC squared BC square equals to EB square plus EC square minus 2 times EB times EC. Minus 2 times EB times EC times cosine alpha. I will repeat again. If we implement the law of cosines in the triangle ABC, we get that BC square equals to EB square plus EC square minus 2 times EB times EC times cosine alpha. We have already found out that cosine alpha here, cosine alpha equals to 4 over 5. Cosine alpha equals to 4 over 5. So we substitute cosine alpha in equation number 3 by 4 over 5. Here EB, side EB of triangle ABC equals to 5 plus 5, that is 10. And side EC it is equals to 4 plus 6, that is also 10. And BC equals to x, so we substitute BC by x. I'll repeat again. EB equals to EC equals to 10 units, BC equals to x, and cosine alpha equals to 4 over 5. So according to equation number 3, BC square, BC is x, so BC square is x square. It is equals to EB square. EB is 10, so EB square is 10 squared, that is 100, plus EC square. EC equals to 10 units, so EC square is 10 squared, that is also 100, plus minus 2 times EB is 10, EC is 10, and cosine alpha is 4 over 5. So in conclusion, we found out that x squared equals to 100 plus 100 minus 2 times 10 times 10 times 4 over 5. So according to equation number 3, x squared equals to 100 plus 100 is 200, minus 10 times 10 is 100, and 100 times minus 2 is minus 200. Four over 5. So according to equation number 3, x squared equals to 200 minus 200 over 5 is minus 40, and minus 40 times 4 is minus 160. So in conclusion, we found out that x squared equals to 200 minus 160. So actually, according to equation number 3, x squared equals to 200 minus 160 is 40. We take a root out of this equation number 3, and we get that x equals to the square root of 40. 40 is 4 times 10. And the square root of 4 is 2. So in conclusion, we found out that x equals to either 2 times square root of 10 units, or in terms of numbers, it is 6.32 units. And that is the answer to the question. That here BC that is equal to x, it is equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. So we finished with the first method. In the next step, I will present to you how to find out the length of this line segment BC according to the second method. In the second method, we will do another construction. From point A, we will draw a straight line on DC in such a way that the straight line will be parallel to BC. So here we define the touching point of the straight line from point A and DC is E. I repeat again that we draw the straight line AE in such a way that AE is parallel to BC. Again, AE is parallel to BC. I write it down that AE is parallel to BC according to our construction. In the next step, from point E, we draw a straight line on BC in such a way that the straight line will be parallel to AB. Okay, so here the red straight line is parallel to AB according to our construction. We define the touching point of the straight line from point E and BC as F. I repeat again, we do the straight line EF in such a way that EF is parallel to AB. So here EF is parallel to AB according to our construction. Actually, it is not very hard from point E to draw a straight line in such a way that it will be parallel to AB. So here EF is parallel to AB according to our construction, and also AE is parallel to BC also according to our construction. So actually we created here quadrilateral AEBF. Quadrilateral AEBF has two couples of parallel sides. The first couple of parallel sides is AE is parallel to BF, and the second couple is AB is parallel to EF. And this is exactly the definition of a parallelogram. So actually quadrilateral AEBF is a parallelogram. Any quadrilateral that has two couples of sides that are parallel to each other is defined as a parallelogram. And here quadrilateral AEBF has two couple of sides that are parallel to each other. AB is parallel to EF, and AE is also parallel to BF. Therefore, quadrilateral AEBF is a parallelogram. Okay. In the next step, I will present to you a new rule number 3. According to rule number 3, According to rule number 3, corresponding angles between parallel lines are equal to each other. And repeat on rule number 3 again. According to rule number 3, corresponding angles between parallel lines are equal to each other. So here, according to our construction, AB is parallel to EF. AB is parallel to EF according to our construction. So according to rule number 3, those two angles are defined as corresponding angles that are located between the parallel lines A, B, and EF, therefore they are equal to each other. That is to say, this angle that is actually angle ABC is equal to this angle that is actually angle EFC. I'll repeat again, because of the fact that AB is parallel to EF, we get that according to rule number 3, angle ABC equals to angle EFC. Why? Because those two angles are defined as corresponding angles and they are located between the parallel lines AB and EF, therefore they will be equal to each other according to rule number 3. But here it is given us the question that angle ABC, this angle equals to theta. So you can write here that angle ABC equals to theta. Angle ABC equals to theta, and from this equation theta equals to angle ABC equals to angle EFC, we will get that angle EFC is also equals to theta. Here, this angle EFC equals to theta. Likewise, side AE is parallel to BC according to our construction. AE is parallel to BC. Therefore, according to rule number 3, those two angles that are defined as corresponding angles will be equal to each other. That is to say, angle DEA, this angle, will be equal to this angle that is actually angle ECB, or angle DCB. This angle is angle DCB. And those two angles are defined as corresponding angles when they are equal to each other according to rule number 3. But this angle, angle DCB, equals to theta according to what is given as the question. So here we know that angle DCB is equal to angle DEA according to rule number 3. But according to what is given as the question, angle DCB equals to theta. So we can write here that angle DCB equals to theta. And from this equation, theta equals to angle DCB equals to angle DEA, we will derive that angle DEA is also equals to theta. Here, this angle, angle DEA equals to theta. Okay? We know that quadrilateral AEMF is a parallelogram because it has two couples of sides that are parallel to each other. Quadrilateral AEBF is a parallelogram and we have rule number 4. According to rule number 4, the opposite sides of a parallelogram are equal to each other. I'll repeat again on rule number 4. According to rule number 4, the opposite sides of a parallelogram are equal to each other. So if we focus on parallelogram AEBF, here P is abbreviation for parallelogram AEBF. In parallelogram AEBF, the opposite sides are equal to each other. That is to say, AB is equal to EF. AB is equal to EF. AB is equal to EF according to rule number 4. But it is given us the question that AB equals to 5 units. So we can write here that AB equals to 5 units. And from this equation 5 equals to AB equals to EF, we will derive that EF is also equals to 5 units. EF equals to 5 units. So we can write here that EF equals to 5 units. In triangle EFC, we have two angles that are equal to each other, and according to rule number 1, in front of equal angles there are equal sides. That is to say, EF equals to EC. So I repeat again that in triangle EFC, this angle EFC, this angle is equal to this angle that is actually angle ECF, and both angles are equal to theta. I'll repeat again, in triangle EFC, angle EFC equals to angle ECF, and both angles are equal to theta. Therefore, we can conclude from it that according to rule number 1, EF equals to EC. In front of equal angles in the triangle, there are equal sides. That is to say, EF must be equal to EC in triangle EFC. According to rule number 1, but we found out that EF equals to 5 units. EF equals to 5 units, and from this equation 5 equals to EF equals to EC, we will conclude that EC is also equals to 5 units. EC equals to 5 units. So we can write here that EC equals to 5 units. In the next step, we will find out the length of the small line segment DE. From the drawing, it is very easy to see that DE, here DE equals to DC minus EC. Again, DE equals to DC minus EC. DC minus EC equals to DE. So DE equals to DC minus EC. So DE equals to DC equals to 6 units according to what is given us in the question. Minus EC. EC equals to 5 units. We just right now found out that EC equals to 5 units. So in conclusion, DE equals to 6 minus 5, this is 1. So we found out that DE equals to 1 unit. So we can write here that DE equals to 1 unit. So in the right triangle, triangle ADE, this right green triangle, triangle ADE, we can implement the Pythagoras theorem in order to find out the hypotenuse AE, the length of the hypotenuse AE. So in the right triangle, triangle ADE, we will get that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say AE squared by PT is Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. This will be equation number 4. So AE squared, it is the square of the hypotenuse, equals to the sum of the squares of the perpendiculars, that is to say it is equals to AD squared plus DE squared. So according to equation number 4, AE squared equals to AD squared. AD equals to 3, so AD squared is 3 squared, that is 9. Plus DE squared. DE equals to 1, so DE squared is 1 squared, that is 1. So in conclusion, according to equation number 4, we found out that AE squared equals to 9 plus 1, that is 10. Here we take out of this equation, equation number 4, and we get that AE equals to the square root of 10 units. AE equals to square root of 10 units, so we can write here that AE equals to square root of 10 units. And here we have, according to rule number 4, the opposite sides of a parallelogram are equal to each other. So if we focus on parallelogram AEBF, the opposite sides of parallelogram AEBF are equal to each other, that is to say AE equals to BF. AE equals to BF according to rule number 4, that the opposite sides of a parallelogram are equal to each other. But just right now found out that A equals to square root of 10 units. So we can write here that A equals to the square root of 10 units, and from this equation square root of 10 units equals to AE equals to BF. We will derive that BF is also equals to the square root of 10 units. BF is also equals to the square root of 10 units. So here we can write down that BF equals to the square root of 10 units. And what is the length of FC? It is very easy to see that the length of FC equals to AC minus BF. Here, FC equals to BC minus BF. I will write it down. And the length of line segment FC is equals to BC minus BF. So FC equals to BC. BC equals to X according to what is given as the question. So we'll substitute BC by X minus BF. BF equals to the square root of 10 units. So in conclusion, we found out that FC equals to X minus square root of 10 units. So we can write here that FC the length of line segment FC is equal to X minus square root of 10 units. So here we know that triangle FEC is an isosceles triangle because of the fact that FE equals to EC equals to 5 units. Okay, I'll repeat again, triangle FEC is an isosceles triangle because of the fact that FE equals to EC equals to 5 units. Triangle FEC is an isosceles triangle because EF is equal to EC. EF is equal to EC equals to 5 units. And the base of the isosceles triangle EFC is FC. Okay, FC is the base, so we can write here that FC is the base of the isosceles triangle EFC. Okay, so in the next step, in triangle FEC, we'll focus on in triangle FEC. and from point E we will draw perpendicular on FC. Okay, so here so from point E we draw perpendicular on FC. So this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. And we define the touching point of the perpendicular from point E and FC as M. So what is line segment EM? Line segment EM is the height to the base FC in the isosceles triangle FEC. I will write it down. Line segment EM is the height to the base of the isosceles triangle EFC. Okay. And we also have rule number 5. According to rule number 5, the height to the base in an isosceles triangle bisects the base. I'll read rule number 5 again. According to rule number 5, the height to the base in an isosceles triangle bisects the base. So here in the isosceles triangle EFC, the height to the base is EF, and the height to the base is EM. EM is the height to the base in the isosceles triangle FEC. So EM is the height to the base FC of the isosceles triangle FEC. And according to rule number 5, the height EM to the base FC bisects the base FC. That is to say, it divides the base FC into 2 equal parts, or in other words, in the isosceles triangle FEC, the height EM to the base FC bisects it into equal parts. That is to say, the base FC over 2. So if the height to the base divides the base into two equal parts, it means that the base that is FC over 2 divides it into two equal parts. So this part FM will be equal to FC over 2, and the other part MC will be also equal to FC over 2. So FC over 2 equals to FM equals to MC. FC over 2 equals to FM, and it is equals also to MC, according to rule number 5. Again, the height EM to the base FC bisects the base. It means that it divides the base FC into two equal parts. So it divides this to two equal parts, so it means that if this part is equal to FC over 2, this part will be also equal to FC over 2. That is to say, FM equals to FC over 2, and MC is also equals to FC over 2. In other words, FC over 2 equals to FM equals to MC according to rule number 2. FC equals to x minus square root of 10. So FC over 2 equals to x minus square root of 10 over 2. And this is equals to FM, and it is also equals to MC. In other words, MC equals to x minus square root of 10 over 2. Very simple. So we can write here that MC equals to x minus square root of 10 over 2. Okay? So, in the next step, we will prove that those two right triangles are similar to each other. We will prove that the green the green right triangle EMC is similar to the green right small triangle ADE. Okay, so we'll focus on triangle ADE, the small right triangle. And the big right green triangle EMC. And we'll prove that those two green right triangles are similar to each other. First of all, in the green right triangle ADE, we know that this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle, this angle, must be equal to 90 degrees minus theta in order to complete the sum of the angles in this right angle 280 degrees. This angle must be equal to 90 degrees minus theta, because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. For the same reason, in the right triangle EMC, this angle equals to 90 degrees, this angle equals to theta, So this angle must be equal also to 90 degrees minus theta. Okay, so here those two angles are equal to each other, they are both equal to 90 degrees minus theta. So angle DAE, in the right angle DAE, is equal to this angle, that is actually angle MEC, and both angles are equal to 90 degrees minus theta. Therefore, they are equal to each other. I repeat again. Angle DAE equals to angle MEC, and both angles are equal to 90 degrees minus theta. Therefore, they are equal to each other. In addition, we have those two angles, they are both equal to theta, therefore they are equal to each other. So angle DEA, this angle, is equal to this angle, that is actually angle ECM, and both angles are equal to theta. I repeat again, angle DEA equals to angle ECM, and both angles are equal to theta, therefore they are equal to each other. And finally, those two angles, they are both right angles, therefore they are equal to each other. So angle ADE, this angle, is equal to this angle, that is actually angle EMC, and both angles are equal to 90 degrees. I'll repeat again. Angle ADE equals to angle EMC, and both angles are equal to 90 degrees, therefore they are equal to each other. So actually we prove that those two angles are equal to each other, they are both equal to 90 degrees minus theta, therefore they are equal to each other. Both those two angles are equal to theta, therefore they are equal to each other. And both those two angles are equal to 90 degrees, therefore they are equal to each other. So all the angles of triangle ADE can run to all the angles of triangle EMC. Therefore, we can conclude from it that the right small triangle, triangle ADE, is similar, this is the sign of similar, to the right big triangle, right green triangle, right big green triangle, triangle EMC. And they are similar to each other according to angle similarity rule. And from the fact that those two green right angles are similar to each other, we will conclude, hence, that AE over EC equals to DE over MC. repeat again. From the fact that the two right triangles are similar to each other, we conclude that AE over EC equals to DE over MC. According to equation number 5, of course. So here AE equals to square root of 10 units, so we substitute AE by square root of 10 over EC. EC equals to 5 units, so we substitute EC by 5. And it is equal to DE. DE equals to 1 unit, so we substitute DE by 1 over MC. And we have already found out that MC equals to x minus square root of 10 over 2. So in conclusion, we found out that according to equation number 5, square root of 10 over 5 equals to 1 over x minus square root of 10 over 2. So here we will move 2 to the numerator, and we will get that according to equation number 5, square root of 10 over 5 equals to 2 over x minus square root of 10. Here we cross multiply this equation, equation number 5, and we get that according to equation number 5, square root of 10 times x minus square root of 10 equals to 5 times 2 is 10. So according to equation number 5, we found out that square root of 10 times x minus square root of 10 equals to 10, and 10 is square root of 10 times square root of 10, so we substitute 10 by square root of 10 times square root of 10, and then we divide this equation, equation number 5, by square root of 10. So we get that according to equation number 5, square root of 10 times square root of 10 is 1, so in this side of equation number 5 we left only with x minus square root of 10, and here square root of 10 times square root of 10 over square root of 10 is square root of 10, so here we will add square root of 10 to this equation, equation number 5, and we get that according to equation number 5, x equals to 2 times square root of 10 units, so in terms of numbers it is equal to 6.32 units. So according to the second method, we found out that x equals to either 2 times square root of 10 units, so in terms of numbers it is equal to 6.32 units. In the next step I will summarize the lecture. We'll start with the first method. In the first method, we made the construction I repeat on the question. We have here quadrilateral ABCD. We know that AB equals to 5 units, AD equals to 3 units, DC equals to 6 units. Angle ABC equals to angle DCB, they're both equal to theta. Angle ADC, this angle equals to 90 degrees, and we want to find out the length of line segment BC that is actually equals to x. Okay, so in order to find out the length of line segment x, we made a construction. We extended side BA and side CD by a straight line until they intersect with each other at point E. So here we created triangle EBC. In triangle EBC we have two angles that are equal to each other. And we actually have rule number 1. According to rule number 1, in front of equal angles in the triangle, there are equal sides. So, if we focus on the triangle EBC, we have two angles that are equal to each other. Angle EBC equals to angle ECB equals to theta. Again, in triangle EBC, we know that angle EBC equals to angle ECB equals to theta. Therefore, according to rule number 1, side EB must be equal to side EC. Okay, side EB must be equal to side EC. But EB equals to 5 plus AE. So we substitute EB by 5 plus AE. And EC equals to 6 plus DE. So we substitute EC by 6 plus DE. We subtracted 5 from this equation, equation number 1. And we got that according to equation number 1, AE equals to 1 plus DE. Then we defined DE as A. Here, DE equals to A according to our definition. So we substituted DE in equation number 1 by A. And we got that AE equals to 1 plus A. So here AE equals to 1 plus A. Okay. So ED equals to A and A equals to 1 plus A. Then we actually, before the construction we had quadrilateral ABCD. Side CD is one side of a quadrilateral, therefore it is absolutely a straight line. And then we extended the straight line CD by a straight line. When you extend the straight line by a straight line, the result must be a straight line. Therefore, the result that is CE must be a straight line. Therefore, we can conclude that CE is a straight line. Line segment CE is a straight line, and we have rule number 2, that the sum of the angles on one side of a straight line is equal to 180 degrees. So here, if you focus on this side of the straight line EC at point D, then the sum of the angles must be equal to 180 degrees according to rule number 2. Okay, so here, so which angles we have at this side of straight line EC at point D? We have here 90 degrees and we have angle EDA. This angle. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. So at point D we have 90 degrees plus angle EDA, and in total they must be equal to 180 degrees according to rule number 2. We subtracted 90 degrees from this equation and found out that the missing angle EDA equals to 90 degrees. So this angle is a right angle, therefore triangle EDA, the green triangle, is a right angle. So we implemented the Pythagoras theorem on the right green triangle, triangle EDA. We implemented the Pythagoras theorem on the right green triangle, triangle EDA. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AE square equals to AD square plus ED square. Okay, AE square equals to AD square plus ED square. AE equals to 1 plus A, so we substituted AE by 1 plus A. If A equals to 1 plus A, it means that AE square equals to 1 plus A square. AD equals to 3, so AD square equals to 3 squared, that is 9. And DE equals to A according to our definition. Therefore, DE squared will be equal to A squared. So in conclusion, according to equation number 2, we found out that 1 plus A squared equals to 9 plus A squared. We opened the brackets on this side of equation number 2 and found out that 1 plus A squared equals to 1 squared, that is 1 plus A squared plus 2A. In the other side of equation number 2, we have 9 plus A squared. So if we have A squared on both sides of the equation, so A squared will get cancelled, and we left only with 1 plus 2A, that is equal to 9. So here we subtracted 1 from this equation, equation number 2, and we got that 2A equals to 9 minus 1, that is 8. 2A equals to 8. So here we divided this equation, equation number 2 by 2, and we got that A equals to 8 over 2, that is 4. So A equals to 4 units. A equals to 4 units, therefore A plus 1 will be equal to 5 units. So in the right green triangle, triangle AED, we know that cosine theta equals to ED over AE. I'll repeat again, in the right green triangle, triangle AED, cosine alpha, here cosine alpha equals to ED over EA. Cosine alpha equals to ED over EA. ED equals to 4 according to our definition. So we substitute ED by 4, EA equals to 5. We substitute EA by 5, and in the conclusion we found out that cosine alpha equals to 4 over 5. Cosine alpha equals to 4 over 5. Then I presented to you a new rule, that is the law of, a new law, that is the law of cosines, that is true in any triangle. If we have triangle ABC, that it could be any triangle, and we know that the length of side AB equals to A units, the length of side AC is B units, and the length of side BC is C units. Then according to the law of cosines, C squared equals to A squared plus B squared minus 2 times AB times cosine alpha. Okay, so we implemented the law of cosines in our triangle, triangle EBC. In our triangle, triangle EBC, according to the law of cosines, we will get that BC squared equals to EB squared plus EC squared minus 2 times EB times EC times cosine alpha. I will repeat again. In the right triangle, triangle ABC, according to the law of cosines, we will get that BC squared equals to EB squared plus EC squared minus 2 times EB times EC times cosine alpha. Again, BC squared equals to EB squared plus EC squared minus 2 times EB EC times cosine alpha. We have already found out that cosine alpha equals to 4 over 5, so we can substitute cosine alpha by 4 over 5. And here BC equals to x, so we can substitute BC by x. EB equals to 5 plus 5, that is 10. And ED and EC is also equals to 4 plus 6, that is also 10. So EB equals to EC equals to 10. EB equals to 10 units, and EC is also equals to 10 units. BC equals to x, and cosine alpha equals to 4 over 5. So here, in equation number 3, we substituted BC by x. So if BC equals to x, it means that BC squared equals to x squared, and it is equal to EB squared. EB equals to 10, so EB squared is 10 squared, that is 100, plus EC squared. EC equals to 10, so EC squared is 10 squared, that is also 100, minus 2 times EB is 10 and EC is 10. So it is minus 2 times 10 times 10 times cosine alpha, that is 4 over 5. So here we have x squared that is equals to 100 plus 100 is 200, and 10 times 10 is 200, 200 minus 2 is minus 200, so here we have this expression equals to minus 200 over 5. So in conclusion, we found out that x squared equals to minus 200, and minus 200 over 5 is 40, and 40 times 40 is 160. So in conclusion, we found out that according to equation number 3, x squared equals to 200 minus 160. 200 minus 160 is 40. So in conclusion, we found out that x squared equals to 40. According to equation number 3, we took out of this equation number 3, and we got that x equals to the square root of 40. 40 is 4 times 10. So here we substituted 40 by 4 times 10. The square root of 4 is 2. So in conclusion, we found out that x, the line segment that we are looking for, it is equals to either 10 times square root of 10 x equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. We finished with the first method. In the next step, I presented to you. In the next step, I will present to you how we found out the length of line segment x according to the second method. In the second method, we did another construction. From point A, we draw a straight line on DC in such a way that AE will be parallel to BC. Again, from point A, we draw a straight line on DC in such a way that AE will be parallel to BC. So AE is parallel to BC according to our construction. And then from point E, we draw a straight line on BC in such a way that EF will be parallel to AB. So again, EF is parallel to AB according to our construction. So here we created quadrilateral AEFB that is a parallelogram. Why quadrilateral AEBF is a parallelogram? Because it has two couples of sides that are parallel to each other. AE is parallel to BF, and AB is also parallel to EF. And this is exactly the definition of a parallelogram. So AEBF, quadrilateral AEBF, is a parallelogram. Okay? Then I presented to you rule number 3. According to rule number 3, corresponding angles between parallel lines are equal to each other. Okay, corresponding angles between parallel lines are equal to each other. So here, according to our construction, AB is parallel to EF. Again, according to our construction, AB is parallel to EF. Therefore, according to rule number 2, because of the fact that AB is parallel to EF, those two corresponding angles must be equal to each other. Why? Because they are located between the parallel lines AB and EF, therefore they must be equal to each other. That is to say, angle ABC must be equal to angle EFC according to rule number 3. Okay? Yeah. angle ABC must be equal to angle EFC because those two angles are located between the parallel lines AB and EFC, therefore they must be equal to each other according to rule number 3. But we have, it is given us the question that angle ABC equals to theta. So we can write down here that angle ABC equals to theta, and from this equation theta equals to ABC equals to EFC, the angle EFC, we will derive that angle EFC is also equals to theta. Here this angle EFC equals to theta. Likewise, according to our construction, AE is parallel to BC. Again, AE is parallel to BC according to our construction. Therefore, those two angles that are defined as corresponding angles must be equal to each other. Okay? According to rule number 3, of course, because of the fact that AE is parallel to BC, angle DEA must be equal to angle BCD because those two angles are defined as corresponding angles, and corresponding angles are equal to each other according to rule number 3. Okay? So, according to rule number 3, we know that angle DCB equals to angle DEA, but it is given us the question that angle DCB, this angle DCB equals to theta. So we can write down that angle DCB equals to theta, and from this equation theta equals to angle DCB equals to angle DEA, we will derive that angle DEA also equals to theta. So this angle DEA equals to theta. Okay? And we have already found out that quadrilateral AEBF is a parallelogram. This is a parallelogram. And we have rule number 4. According to rule number 4, actually, in triangle AEC, I repeat again that quadrilateral AEBF is a parallelogram, and we have rule number 4 that the opposite sides of a parallelogram are equal to each other. Okay? Here, the opposite sides of parallelogram AEBF are equal to each other. That is to say, AB equals to EF. According to rule number 4, AE equals to BF. Here, AB equals to EF. Okay, AB equals to EF according to rule number 4, that the opposite sides of a parallelogram are equal to each other. But it is given us the question that AB equals to 5 units. Okay, here we can write down that AB equals to 5 units according to what is given us the question. And from this equation 5 equals to AB equals to EF, we derive that EF is also equals to 5 units. Here EF is also equals to 5 units. Okay. So in triangle EFC, we have two angles that are equal to each other, they are both equal to theta. But before that, in triangle Okay, so in triangle EFC, we know that angle EFC equals to angle ECF and they are both equal to theta. And we have rule number 1 that in front of equal angles in the triangle they are equal sides. So because of the fact that those two angles are equal to each other, according to rule number 1, EF must be equal to EC. Again, according to rule number 1, EF must be equal to EC. But we just right now found out that EF equals to 5 units. So we can write here that EF equals to 5 units. And from this equation, 5 equals to EF equals to EC, we derive that EC is also equals to 5 units. So EC equals to 5 units. Okay, so if EC equals to 5 units, what is the length of the small line segment DE? DE equals to DC minus EC. Okay, DE equals to DC minus EC. So DE equals to DC, that is 6 units, it's according to what is given as the equation, minus EC, that is 5 units. Minus EC, that is 5 units, so DE equals to 6 minus 5, that is 1. So DE equals to 1 unit, so in the right small triangle ADE, DE equals to 1, AD equals to 3, so we'll implement the Pythagoras theorem in this right small triangle in order to find out the hypotenuse AE. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AE square equals to AD square plus DE square. So here, AE square equals to AD square. AD equals to 3, so AD square is 3 squared, that is 9, plus DE square. DE equals to 1, so DE square is 1 squared, that is 1. So in conclusion, we found out that AE square equals to 9 plus 1, that is 10. So according to equation number 4, we found out that AE square equals to 10. We took out of this equation number 4, and we found out that AE equals to the square root of 10 units. So here, AE equals to the square root of 10 units. So in parallelogram AEBF, we know that the opposite sides are equal to each other according to rule number 4. That is to say, AE equals to BF according to rule number 4. In parallelogram AEBF, the opposite sides are equal to each other. That is to say, AE equals to BF according to rule number 4. But we have already found out that AE equals to square root of 10 units. A equals to square root of 10 units, so from this equation, square root of 10 units equals to AE equals to BF, we will derive that BF is also equals to the square root of 10 units. Here, BF equals to the square root of 10 units. Then we found the length of line segment FC. FC, it is very easy to see from the drawing that BC minus BF equals to AC. Again, BC minus BF equals to FC. Okay, here FC equals to BC minus BF. So FC equals to BC. BC equals to X. According to what is given as the equation, BC equals to X. So we substituted BC by X, and BF, we found out that BF equals to square root of 10 units, so we substituted BF by square root of 10 units. So in conclusion, we found out that FC equals to X minus square root of 10 units. Here, FC equals to X minus square root of 10 units. So here, triangle EFC is an isosceles triangle because of the fact that EF equals to EC equals to 5 units. Triangle EFC is an isosceles triangle because of the fact that EF equals to EC equals to 5 units. And FC is the base of the isosceles triangle, triangle EFC. FC is the base. Then from point E, we do perpendicular on FC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. So actually, EM, line segment EM is the I to the base FC. In the isosceles triangle FEC, line segment EM is the I to the base FC. The base is FC, so EM is the I to the base FC. Why? Because it is perpendicular to the base FC. And this is exactly the definition of a height. So EM is the I to the base FC. EM is the I to the base FC of the isosceles triangle EFC. EM is the I to the base of the isosceles triangle EFC. And according to rule number 5, the I to the base in an isosceles triangle bisects the base. So according to rule number 5, the height EM to the base FC bisects the base FC. So EM bisects the base FC. So it means that it divides the base FC into two equal parts. So FM will be equal to BC, FM will be equal to FC over 2, and MC will be also equal to FC over 2 according to rule number 5. Why? Because the height EM bisects the base FC. It means that it divides it into two equal parts. So if FM equals to FC over 2, then MC will be also equal to FC over 2. That is to say, FM is equal to FC over 2, and MC is also equal to FC over 2 according to rule number 5. FC equals to x minus square root of 10 units, so FC over 2 equals to x minus square root of t over x minus square root of 10 over 2. So here, x minus square root of 10 over 2 equals to Fm equals to MC. That is to say, MC equals to x minus square root of 10 over 2. So can I tell that MC equals to x minus square root of 10 over 2 units. Then we proved that those two green right triangles are similar to each other. Why those two green right triangles are similar to each other? First of all, both of them have those right angles, therefore those two angles, they are both right angles, therefore they are equal to each other. Those two angles, they are both equal to theta, therefore they are equal to each other. And this angle, in this right triangle, this angle equals to 90 degrees, this angle equal to theta, so this angle must be equal to 90 degrees minus theta. Likewise, in this right triangle, this angle equals to 90 degrees, this angle equal to theta, so this angle must be equal to 90 degrees minus theta. So those two angles are also equal to each other. So all the angles of triangle ADE can equal to all the angles of triangle EMC. Again, I repeat again. Angle DAE equals to angle EMEC equals to 90 degrees. Those two angles, they are both equal to 90 degrees minus theta. Therefore, they are equal to each other. Angle DEA equals to angle ECM equals to theta. Those two angles, they are both equal to theta, therefore they are equal to each other. And angle ADE equals to angle EMC equals to 90 degrees. Those two angles, they are both equal to 90 degrees, therefore they are equal to each other. Therefore, triangle ADE is similar to triangle EMC according to angle similarity rule. And the fact that those two right triangles are similar to each other, we will conclude hence AE over EC equals to DE over MC again. AE over EC equals to DE over MC. According to question number 5, AE over EC equals to DE over MC. Here AE equals to square root of 10 units, EC equals to 5, DE equals to 1, and MC equals to x minus square root of 10 over 2. Here we moved to the numerator, and we got that square root of 10 over 5 equals to 2 over x minus square root of 10. because multiplied this equation number 5, and we found out that square root of 10 times x minus square root of 10 equals to 10. Here 10 is square root of 10 times square root of 10, so we substitute the 10 by square root of 10, and we got that, according to equation number 5, square root of 10 times x minus square root of 10 equals to square root of 10 times square root of 10. Here we divided this equation number 5 by square root of 10, and found out that here square root of 10 over square root of 10 is 1, so here what is left in this side of equation number 5 is only x minus square root of 10, and here square root of 10 times square root of 10 over square root of 10 is square root of 10. So what is left in this side of the equation is only square root of 10. We added square root of 10 to this equation number 5, and found out that x equals to square root of 10 times square root of 10 plus square root of 10 is 2 times square root of 10. So in conclusion, we found out that x equals to 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Okay? So in both methods, we found out that x equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Okay? Thank you very much.